All right, I've spent the last couple days with a little project here. I didn't film any of the putting together. It's pretty straightforward, and people have done this online before, so it's just kind of following other people. I have discovered, though, that a lot of the sites that I visited, you couldn't ever accomplish. If you followed their instructions, you're not going to get there. So then I thought, well, maybe I should document this thing and show it. I did want to show it anyway. It's kind of a fun project. It has all to do with this module here. You can buy these modules now. These are basically a radio on a chip. These are modules, and so it's the entire radio. This particular version does a UHF version, so it's like 400 to 480 megahertz capable, and you basically talk to it with a serial port. So it has a serial port. 9600 baud. You tell it what frequency you want, and you tell it there's a pin that says transmit or receive, and there's a pin that says audio out, and a pin that says audio in, and that's about it. That's about it. So I decided to use this one of my favorite boards now, this TTGO board. It's a ESP32 card, so it has a serial port that sends and receives from the chip, and it has its own SPI display on it. So that's handy. The other thing that I had to add here was a audio amplifier and a speaker. So this is an LM386, of course, and then here's a volume adjust. To get it right. Now there is also a volume adjust in the software, so with software control you can change the volume in 8 different steps. You can change the squelch, do all that other kind of stuff. I have a little rubber duck antenna on it right now, and so let's turn it on so you can kind of see what it does. I'll probably have to change lenses here so you can see it on the screen, but it comes up with a flash screen. It then starts to initialize the chip. There's a bunch of things here you're not going to understand, and then sets the frequency and the volume, and now it's in receive mode, so it's receiving on a particular frequency. And if I push this button here, the microprocessor is in a loop right now, polling this, and when I push it down, it goes into transmit mode and transmits. We'll measure the output power, we'll measure the frequency, stability, we will measure much stuff since we can now. So it's nice to do a project and then try to take all of these learnings that I've been trying to give you guys and put it all together. It's like, now that we have all of these ideas and all of these arsenal, we can put them to use. We can use a spectrum analyzer. We can do a function generator. We can test different things. So when I was bringing up the board, I didn't have this on it yet. There's a connector right back here that you can put a USB to TTL RS-232 type chip thing over here. So you can talk to the chip directly by going onto this port. So I did a lot of development with that first, and then went to the Arduino. I guess you call them Arduinos, ESPs. It's all written in Arduino code and in the Arduino development platform and stuff. So let's see here. What would be the first thing to do? Well, spectrum analyzer is right here on the bench, and I don't have to move the camera around and stuff. So let's do spectrum analyzer stuff first. So let me go turn the spectrum analyzer on and hook up some cables. All right. So the very first thing when you hook up to a spectrum analyzer, you first have to stop and say, okay, how much power do we have? Is it more than 0 dBm? Yes. This thing is somewhere probably around 1 watt, something like that. So definitely we need protection for the spectrum analyzer. So I'm going to be using a 30 dB attenuator. So this attenuator is good to 2 watts. So I know that it'll be fine. So when we do the spectrum analyzer measurements, we need to remember that we have a 30 dB attenuator in series, so things are 30 dB more than they measure. All right, and we will put on our nice cable. Okay, so like I said before, I just push this button and it tells the module to transmit. So let's push the button and there we go. We'll get some carriers and some harmonics and stuff, which makes sense because there's no filtering on this thing. If you turn this thing into an actual radio, you would need to put a low pass filter on the output. And we can see right here, we're going to need to do that. So let's go ahead and make one quick measurement. I'm going to hold down the transmit and I'm going to hit single sweep. And now I can let go of the transmit button so it keeps the signal. Just like a single sweep on an oscilloscope, single sweep on the spectrum analyzer. We can do a peak search, and so our peak is happening around, it says 423, which is in the neighborhood. This is very, very low resolution because we're spanning a lot. We can go to the next peak, which is at 841 megahertz, and then we can go to the next one, which is at 1.26 gigahertz. All right, and so let's see how bad it is. So we will go left here, and we will do a delta marker, and then we will go right, and we are minus 24 dB. So the first harmonic is minus 24 dB. Now, specifications for radio and stuff, you need to be around minus 43 dB or something like that. And so, yeah, we're going to need to put a filter in here and see if we can't knock that down. All right. So it just so happens, if you remember my video on a series on all of these little boxes that I made, this one is a focused here. All right, so this is a 550 megahertz low pass filter. So remember, our first harmonic is up around 800, and so this should be a good value to use. So what we'll do is we will disconnect the spectrum analyzer and put a filter in series. So this is just kind of a feasibility study. If we built this into a radio, we would need to somehow duplicate this on the circuit board. And I've done some videos on low-pass filters, little LC filters that are just everywhere. I did not use the word ubiquitous. They are everywhere, and they're easy to build, very easy to build. Okay, so now that we have this in here, this is what we used to have. And now I'm going to transmit and do a single sweep again. And you can see, bang, our harmonic is way, way down. So let's do our measurements again here. Let's see here. Let's turn off marker. Let's go to normal marker. We'll do peak search up here. We'll do delta marker, and then we'll do peak right. And now we're minus 55 dB down. So this filter would work out just great. Okay, let's go ahead and kind of take a look at that carrier a little closer. Let's go back over here, and we will go to, out of single sweep, we will go to continuous run. There we go. All right, so we will do a peak search. We will move to the center, and we will zoom in on that. All right, and we will do a peak search, marker functions, tracking on, counter on, And we will zoom in on that. And we need to turn the marker to normal and do the peak search, and we are, all right. So we're taking a look at the signal. The signal looks very, very clean. We can do a single sweep now. I don't like to transmit it longer than I have to when I make measurements. So that's really handy to have a single sweep button on the front panel of the spectrum analyzer. So here's our peak. It looks pretty clean. 10, 20, 30, 40, 50, 60, 70. And it's like 80 dB, the noise floor. It looks very clean. So a couple of little spikes down here, but nothing to worry about. And our counter is telling us we are at 421.1252. And I have it programmed to 421.125. So 1252, 125. So we're 200 hertz high. So that's pretty good. Not too bad for a little radio. All right. I don't have any modulation set up here, so we can't measure that. But right now, it looks we have a very clean carrier, and we will have to have a filter in the final product. And yeah, so let's now that we've kind of done this type of test, let's see how many watts this thing outputs. All right, we're going to be doing a power measurement, and we're going to be running this into the HP8921, which is a radio test set. Make sure you make sure you double check the instrument that you're putting it into, and make sure your cable is going to where you think it's going to go. The instrument is good to 60 watts. I can put in 60 watts into the instrument, no problem at all. And so we can connect the coax directly to the board. We don't have to use that 30 dB pad. We're directing all of the RF down the cable. And the cable goes over here, and then the cable goes up over to there, okay? So let me move the camera, and we'll take a look at the test set. Okay, we're going to be doing a transmit test. We'll hit the transmit button, and displayed here is going to be the frequency that it receives and the power that it receives. So really we need to take a look at those two numbers. And so let me press the transmit button. And there we go. So 421.1252. A little more accuracy here, but that's what the spectrum analyzer said. And about 0.3 watts, 0.2. Started up. It's warming up, right? So let's press it again. Yeah, around 0.29 watts, right? This is in watts. So, not too bad. I expected it to be more like 1 watt. Maybe it's on low power. I don't remember how I have it set exactly. There is a high power, low power. I believe it's on high power, but I'm not entirely sure. All right. So we can, we verified that it has power. We can also do a spectrum analyzer from over here too, just to double check. And there we go. Looks about the same. Looks very, very nice. And we don't have any modulation yet, but what we can do now is we can use the test set in the reverse direction. Okay? So now we're going to do some receiver tests. We can set the frequency to 421.125 megahertz. And you hear it come on? Okay, so you're listening to the actual little receiver over there. And why are we hearing something? We're outputting minus 80 dBm, okay? And so we can go down to that box there, all right? And we can change that to microvolts. And so we're at 22 microvolts, that's pretty high. Let's lower that number. And I still hear it. I still hear it. Okay, this is 1.78 microvolts. I think you hear that it's a little bit raspy, And then here's 1 microvolt, and it's pretty raspy. And let's see where the squelch breaks. So the squelch is breaking right around half of a microvolt, maybe a third of a microvolt, something like that. So, you know, it's respectable. It's doing okay. All right. So let's go ahead and turn this up, say 4 microvolts. Let's turn off that. And then we can do decoder, let's see, encoder. We can do the DTMFs, and we can send those to, let's see here, we started with, oh, I have to do this. I need to say on, there we go, I need to say on, that was it. I can, so you hear that? All right, so it does seem to do what it's supposed to do. Okay, so I promised a look at the display here when it's firing up. So let me change lenses and I'll show you it. I'll show you it firing up. All right. Let's see. So what we can do is we can hit the reset button and we can watch it go through its flash. The module is an SA818. And so let's go through this kind of, let's just take a look at the first screen. The first screen is IMSAI, and it did a connect, and then it did a version number. So the first command that it has to give is, I want to connect to you. And then I do a read. And what I read back is DMO connect 0. If you see a 0, that means you've gotten the command across. It understood the command. If you get a 1, it said, I didn't understand what you said, okay? So I'm saying, I want to connect, and it says, okay, connected, 0. And then what I do is I ask it for its version number, okay? And so it says, your version v4.2, right? So that's the second command. Then it goes on to the next screen. The next screen is going to set a group command, and it's what bandwidth, what receive frequency, what transmit frequency, what tone for transmit, what tone for receive, and the squelch setting. And it's all in one command, all right? And so it's after this one. It's this one here. I'm trying to set that frequency and I get a 0. The group 0. So it meant that you've given me a group command. I'm going to pass you a 0, means I understood it, okay? And then the last thing I do is set the volume. So let me show you that. Okay, group, and then volume 3, and then it says volume 0. It says, okay, I understood you. I set the volume to level 3 is what you asked me to do. So I'm telling you I did that. And then it just says, okay, now it's just going to an infinite loop and it's receiving. And if it hears anything, it'll come out on the radio. And then it's looking for this button presser. There's 2 buttons on this little Arduino. And you push this button and it says, okay, I know you want to transmit. And I'm not going to do it right now because I don't have a dummy load on it. But there you go. So I think that's a good first video for the introduction of this thing. I'll do another video on the hardware of this thing, what the data sheet looks like, what the schematic looks like. I'll do a rough schematic. I haven't even drawn one for myself yet. I don't have a schematic for this thing. It's so simple. And the LM386s, they've been around for decades, so easy to find a schematic for that. There is a 10K resistor here to do a volume out of the volume out of here goes through a 10K, so you're going to adjust the volume here into the right range. And then inside the chip is the digital volume control. And then it uses some Arduino. Any old Arduino will do. I just happen to like this one because it has the built-in display, so I don't have to wire anything. It's all set to go. You can get these for about $7, $8, something like that.